Ever wished you had a sidekick? You know, one who could not only understand complex research, but could also get the humor in a meme.
Who hasn't? Sign me up for that waiting list.
Well, get this. Today's deep dive is all about LVA. That's LLaVA. Large Language and Vision Assistant, an AI that's aiming to be just that multi-talented. We're going deep into a research paper and even getting into the supplementary materials. Always fun.
The extra goodies are the best. You know the researchers really want their work to shine when they put in the effort for those, and this paper, let's just say, does not disappoint.
Okay, so LLaVA. This AI is designed to be your multimodal assistant. But for our listeners, what does that even mean? Multimodal.
It all starts with this. We've got AI that's amazing at image recognition. Think those apps that can tell you what kind of plant that is just from a picture. And then we've got the AI language stars like ChatGPT composing everything from poems to emails, but getting them to work together, to understand instructions that use both text and images. That's the next frontier.
That's where LLaVA comes in. And the paper calls this multimodal instruction following.
Right. Exactly. It's like if you're explaining something to a friend, right? You wouldn't just use words. You'd show them pictures too. Use gestures, change your tone of voice. LLaVA is about making AI understand instructions that are more like that, more like how we communicate.
So bridging that gap between how we experience the world using all our senses and how AI can do the same, to follow instructions that combine images and text. Kind of a no-brainer when you think about it.
It is a very human approach to AI, and the paper really dives into how they trained LLaVA to do this, because it turns out there wasn't a lot of data out there for this kind of multimodal instruction following.
So how do you teach an AI to see and speak our language? It sounds incredibly difficult.
It is. It's a classic AI problem. You need data, lots of data, to train a model, but sometimes, well, that data just doesn't exist, not in the way you need it.
I'm intrigued. What did they do?
In this case, there wasn't a data set specifically for training AI to, get those combined image and text instructions. Yeah. So they got creative. They looked at what was out there, tons of image caption pairs,
okay,
the kind of thing you see all over online picture description. And they thought, how can we use this to train LLaVA?
Okay, I'm following so far. Images, captions.
And this is where it gets really clever. They brought in GPT-4.
Hold on. GPT-4. The AI that writes poems writes code. They use that to teach another AI.
Exactly. It's like GPT-4 was running a boot camp for LLaVA training montage. Remember those image captions we talked about? Those captions, they gave GPT-4 some context to work with.
Right. The captions paint the picture, so to speak.
Exactly.
But how do you go from captions to instruction following?
They used bounding boxes. It's basically a way to point out specific objects in an image, like drawing a box around something in a picture and saying, hey, LLaVA, pay attention to this.
So they're highlighting the important parts of the image.
Yeah. GPT-4 used those captions and those bounding boxes to create 3 main types of training scenarios for LLaVA.
Okay.
Conversation, detailed description, and complex reasoning.
Ooh. Training montage. Give me the details. What did these scenarios look like?
So picture this, the conversation scenario. It's like LLaVA is having a casual chat with someone about an image, asking, what kind of car is this? Or how many people are in the picture? Very natural conversational questions.
It's like what you do while flipping through photos with a friend.
Exactly.
Okay, got it. What about detailed description?
Detailed description is where LLaVA needs to flex those descriptive muscles. Imagine someone saying, okay, tell me everything you see in this image down to the smallest detail. That's detailed description.
Okay, and complex reasoning. I'm almost scared to ask.
Yeah, complex reasoning. This is where it gets intense. LLaVA has to go beyond just describing what it sees and actually start to, understand the image on a deeper level.
Wow.
These training scenarios might involve questions like, why are these people gathered here? Or even what might happen next? It requires LLaVA to tap into, common sense to understand relationships between objects and make inferences.
Wow. They really threw everything they had at LLaVA. So after all that, what were the results of this AI bootcamp? Did it actually work? So they really put LLaVA through the ringer with this training. Did it work? Did LLaVA pass the test?
LLaVA graduated with honors, and one of the most interesting tests they used was actually, get this, memes.
Wait, memes?
Yeah.
Like the funny images people share online. How do you even begin to teach an AI about memes?
Right. Humor can be so subjective.
Yeah.
But they found a way. They showed LLaVA different memes and asked it questions, testing its ability to understand not just what was in the image, but the humor behind it.
So what happened? Was LLaVA laughing along with the humans?
Well, it didn't exactly burst out laughing, but it got surprisingly close. The paper gives an example with this meme, a guy ironing clothes on top of a moving car, a classic. And they compare LLaVA's response to other advanced models, OpenFlamingo, BLALIP2. The difference is stark.
I'm guessing those other models just gave like a literal description of what was happening, totally missing the joke.
Totally. Couldn't see beyond the individual elements. LLaVA got it. The absurdity, the unexpected juxtaposition. In many cases, its responses were very similar to what a human would say.
So even though it was trained on a relatively small data set, it was still able to pick up on these really nuanced things like humor.
It's pretty impressive, right? And it gets even better. Remember we talked about Science QA, that massive data set of science questions?
Yeah.
LLaVA achieved near state-of-the-art accuracy on Science QA. It even outperformed some significantly more complex models. It's not just, understanding memes and jokes. This thing is capable of grasping complex scientific concepts.
This is a smart AI.
Yeah.
But were there any limitations? I mean, nothing's perfect.
Of course, there's always room for improvement. One thing they found was that LLaVA can sometimes, stumble with images that are very complex or require a lot of external knowledge. Like, say there's a picture of a product with a really obscure logo. LLaVA might not be able to identify the brand.
So it has some blind spots. That's to be expected.
Exactly, and honestly, those limitations are great. Helps us understand where to focus future research. How do we give LLaVA a broader understanding? How do we help it, tackle those complex scenarios? It's exciting.
Definitely sounds like we're on the cusp of something big. So for our listeners who, are ready to dive into the future of AI, what's the takeaway here? What does LLaVA really mean for us?
It gives us this incredible glimpse into the future of AI assistance. It's not just about words or pictures separately anymore. It's about bridging that gap, just like our brains do, seamlessly. Imagine an AI that can not only help you find information, but truly understand it, no matter if it's text, images, you name it.
It's like having a research assistant, a creative partner, and a super smart friend, all in one. The possibilities are, well, they're endless.
Exactly. That's what makes this research so groundbreaking. This isn't just some cool AI. This is a major step towards creating AI that is more intuitive, more helpful, and ultimately more human-like in its ability to perceive and understand the world. It's a future worth getting excited about.
It certainly is.